This is my magnetic track. I saw these things on made by other people on YouTube, and I was fascinated by them. And some of the other videos state or imply that these are free energy devices. And so I thought I would investigate myself as to whether or not they were. Now, there are two kinds of ways that these work. One way is attraction. That is, the idea you have a slider magnet. It's attracted into the track and gets going so fast that it just keeps going. The other way is repulsion, whereas you have to force it into the track, but once it gets into the track, repulsion forces it out. Now, with the attraction method, I was never able to get the slider magnet all the way out. It would always get stuck. Sometimes it would go out to about here, and you'd think it would just about to break free, and then it would be pulled back into the magnet. Now, it does work with repulsion, whereas you have to force it in, and then it shoots out. But the trouble with repulsion is that it uses a lot of energy to force the magnet into the magnetic track. And I question whether or not you were really getting a net energy gain. In other words, I suspected that this track used more energy to put the magnet in than you were getting out in the repulsion method. The magnets don't last forever. They're like storage batteries. They store energy in them. They won't last forever, but a good set of rare earth magnets will last a long time, say 6 months. You could use them 24 hours a day, pushing magnets through for, say, 6 months or so. So this would be a very valuable device if it was true that it used less energy to push in the slider magnet than you got out. When you watch this on your screen, you can't get any idea of the forces, the magnetic forces involved. It seems very easy to use the magnets. But in real life, when you're here, you can feel very strong forces of repulsion. And I'll show you, give you some idea of the repulsion forces involved in a moment. I am showing how the magnetic field from the track magnets repels the slider magnet at a distance of 5 inches. Most people insert the slider magnet right where the track magnets begin, but this does not save any energy. My hand muscles overcome the repulsion of the magnetic field and force the slider magnet into the magnetic track where it is shot out the other side. How much energy did my hand use to do this? There is a way to determine this. If I drop a weight straight down, if it is heavy enough, it can pull the sliding magnet into the magnetic track. I know how much weight it takes because I carried out experiments before I made this video. It takes a 10-ounce weight to do the job. The 10-ounce weight has to pull the slider magnet 5 inches. This means the energy used to force the slider magnet into the magnetic track is 50 inch ounces. The wood cover is put on top of the track because when the dropping weight pulls the sliding magnet slowly through the track, the sliding magnet flips over end to end. The cover prevents this. To determine how much energy the sliding magnet delivers when it is shot out of the magnetic track, I hook the track up to a ballistic pendulum. The weight on the pendulum is the same 10-ounce weight used before. To achieve break-even energy use, the sliding magnet must push the pendulum weight completely past 5 inches. This distance is shown by the metal strip. The nail is at the 2-inch mark. We see the sliding magnet fails to push the pendulum weight completely past the 5-inch mark. Now what should happen, the magnet comes out, it should knock this back 5 inches, like that. But it doesn't do that. It only comes about and then twists, like that. The twisting doesn't affect the general outcome. If it was hit with enough force, it would still go. Even if it twisted, it should be driven back like this, even if it twisted. I did this experiment a dozen times, and it was always the same result. The conclusion is that it takes more energy to put this slider magnet in than you get coming out. So this would not work as a free energy device, nothing more than a toy, the way it works now. Now, some people might say that I did the experiments wrong. Some people might say that they could make the magnetic track better as far as design, or they could use more powerful magnets. And it's valid to say all that. Somebody could possibly improve on all this to get it to work so that it is a free energy device. However, what I showed here today should make anyone watching skeptical when they see any other magnetic track working and the person says that their magnetic track is a free energy device or implies that it is. You should be skeptical of that. I watched the finished video and realized that I might have made a mistake in the way I carried out the experiment, in that the ballistic pendulum weight was all made of steel. The bolt and the washers were all made of steel, and that may have retarded the weight flying backwards because it would have been attracted to the magnet. To solve that problem, I replaced the steel weight with a piece of wood and a piece of copper. I did that because that combination turned out to weigh the same as the original steel weight. Now, if you know about the eddy current, the moving magnet can generate a magnetism in the copper. However, that magnetism would be repelling. It would repel away from the moving magnet. You can see that the result is almost exactly the same. The pendulum weight made of wood and copper is driven back almost the same distance as the all steel weight was. So the result is the same. It takes more energy to put the slider magnet in the device than the energy you get out of the device.